So the point of this activity was to get you to hopefully recognize that we have a line here, y equals negative 2x plus 3. Here it is graphed. We saw in the beginning that all the points on the line are solutions to the equation. Hopefully we remembered that, but if we didn't, saw it again in the beginning. But any point on here is where y equals negative 2 times x plus 3. That's where those two things are equal, is right here. So when we try to look at these points for the inequality where y is greater than or equal to negative 2x plus 3, well, this is the line, or y is equal to it. And you might have noticed that on one side, we have some that are greater than or equal to, and on the other side, it does not fit that. So you might consider, these are not greater than or equal to, which means they're the other side, right? It means they're less than. So we have where it's equal, and we have where it's greater, and we have where it's less than. It's just in two variables this time. So let's look at that and compare it to what we've seen already with graphing one variable here. So if we had something like this, we started out by saying, well, what if we find out where it's equal? We can subtract 3 from each side and say it's 2. And we have what we called a boundary point, right? We called that a boundary point. So that is 2. And we had to decide, is this an open or closed circle? Well, it depends on whether it should be equal to or not. In this case, it's a strict inequality. It's not allowed to be equal to. So x equals 2. Or that's the boundary point, but it has to be greater than. So it's not allowed to be equal to. This is going to be an open point at the boundary point. And then we would have to say which side is, in this case, it's going to be greater than. So we would test a point and say, well, what about 5? If we did 5 plus 3 greater than 5, then 8 is greater than 5, and this side works. So we can shade on this side and say that these are all my solutions over here. Similarly, if we had something like that and it said x, we subtract 3 from both sides, less than or equal to 2, we would say, okay, we've got to shade it in right here. If we tried 5 again, plugging in, we would get 8 less than or equal to 5, which is not true. So we know it would have to be on this side. And that's the difference. Is it open or is it closed? We're testing sides. Which side does it fall on? So if we look at an inequality in two variables, what we can do is a similar thing. Where is the boundary? Where is the boundary? Well, the boundary is going to fall at where y is x plus 3. Well, where is that? Well, let's see. We're going to have a y-intercept here, and then we're going to have a slope of 1. So it's going to go like this. And we've got some boundary right here because this is where it's equal. Just like we did over here, it's like, okay, well, it's equal at 2, right? It's equal at 2. Well, there's a small difference here. Over here, we had to say, is this an open or a closed circle? Here, we have to ask ourselves, is this a solid or dotted line? I've written that below, but it looks like it doesn't want to be part of here. Is this a solid or dotted line? And we ask that the same way that we ask this, open or closed circle, solid or dotted line. Is it allowed to be equal to? So in this case, it's a strict inequality where y is strictly greater than x plus 3. So it's the points on the line don't fit in here. Because if it's equal, then it's not greater. Here it would, here it does not. So in this case, we would say this is a dotted line right here. And what that's telling me is it's strictly greater than, that the line is not part of the solution. And then what we can do is test a point in there. Just like we said, okay, well, what if we tested 5? Does it work or not? If it does, then it's this side. If it doesn't, then it's the other. We can do the exact same thing. what I really like to do is use 0, 0 always because it cancels out the x. And you can just really see, you know, sometimes, you know, when you're graphing a line, you've got like 3/5 x or something. And it's like, well, do I really want to multiply by 3/5 and then add it and figure that out? Or you can just use 0, 0 and determine it. Because when I plug in 0, 0, I'm going to get 0 greater than, because we graphed this one, 0 greater than 0 plus 3. So is 0 greater than 3? It's not. So this point doesn't work, and that means we're going to shade on this side. And we're going, you know, you can kind of shade like that, or you can color it all in or whatever you want to do. I like to just kind of draw some lines over there. Say, this is my solution side over here because this point did not work. And there you go. Now the difference would be, whoa, that's not an eraser. The difference with something like y is less than or equal to x plus 3 would be if it's allowed to be equal to now. So if it weren't this and it were this, it's allowed to be equal to now. I would call this boundary line solid. This is solid now. It's just like how we would fill in the boundary point if it was allowed to be equal to. We make this a solid line if it's allowed to be equal to. Now, in this case, it says less than. So if we were to try 0, 0, right, it would be 0 less than or equal to 0 plus 3, and 0 is less than or equal to 3, and that works. So since this one works, we know this is the correct side, and we can shade this side for the inequality. And that's how you graph an inequality in two variables.